to give you the word really nice word. Oh, and I want another P. Enjoy it. Kalapige. The word for kindness in Lebanese, in ancient Greek. Yes, absolutely. Kalipige. Yep, kindness. So what I want you to do with this one word, just with this one word, is I want you to tell me all the different words you can make with it, where the P's must be together. All the different ways you can rearrange kalapige. P's together.
What does that mean?
P's must be together?
All three of them?
Yep. All the P's. And then we're going to go back a page after this to the mapping questions. We did 72 divided by 2 is 21.75. Someone's math skills are really off. Even a 0.75. You're going to make it true? Okay.
He's making a new basis.
Right. Good luck. The moment that I am given a word, I will always stack letters first. So I'll always rewrite out my word. P, A, L, L, A, P, Y, J, P. And the moment I stack my letters, I know, go to the denominator and put factorials. I don't even do any of the actual math towards this. I go put the factorials and brackets in the denominator because that's the most common mistake, is to forget to do that after you've done all the other work. So I go to my denominator and I go in brackets, 3 factorial for the P's, 2 factorial for the A's, 2 factorial for the L's, close brackets. Now, if you use the fraction button on your calculator, you don't need the brackets. You don't have the fraction button calculator on your calculator, or you're like, I don't like it, just use brackets in your denominator, right? And your numerator in this case, because we're going to have more math. Now, this has 9 letters. 1, 2, 3, 4, 5, 6, 7, 8, 9. And what I tell you to do at the top, I told you to treat all the letters as if you can tell the difference. So like I look at the 3 P's and I could easily tell if I moved them, right? Like we pretend that we can see the difference between them, that they all look different, and then the dividing by the factorials in the bottom gets rid of the cases where you actually can't tell the difference. Okay? So I wanted the P's together. So I hooked them together. How many options would I have for the first one? 3, then, because we're pretending we can tell the difference, right? Now how many letters do we have left? 6. So then we'd have 6, then 5, then 4, then 3, then 2, then 1. And if I said together at the front, we'd be done, right? You have to watch because most people are really good at multiplying by the time the test comes. And then they'll say together at the front, and you'll multiply by it. And I'm like, oh, I can't do that. So make sure you read. If it just says together, you're going to multiply by what? 7. Always one more than the number after the hook together numbers, because this would be 1, then 2, 3, 4, 5, 6, 7. So you're going to end up with 3 factorial, 7 factorial, over 3 factorial, 2 factorial, 2 factorial, which the 3's can actually cancel because it's multiplication. Boom, boom. So you could type it into your calculator as 7 factorial over 4 if you really wanted to. Which is? What'd you get?
1,260.
Yeah. And we're going to flip back a page. I just wanted to remind you if I give you a restriction on a word, so you didn't really look at what it was yesterday. We just did basic words. So we're going to go back. So I want you to try this, this, and this. Here's your practices. All right. So the first one is similar to what we just did, except this time it's the A's must be together. The catch with B, it says it must start with the V's, correct? So the V's can be together, but we're not going to move them, is the catch. So we're going to have 2 times 1 times, I don't remember how many letters there was before. 7, 6, 5, 4, 3, 2, 1. And then we don't move them because it must start with the B's. So it'll be 2 factorial, 7 factorial over 2 factorial. The 2 factorials can cancel and you get 5,040. Mathematical, the vowels must be together. M, A, T, H, E, M, A, T, oops, T, I, C, A. That worked out way better than it should have. L. So I'm going to go here, boom, and I'm going to go 2 for the M's, 3 for the A's, 2 for the T's. And I need vowels, so I have A, E, and I, so there's 5 of them, right? And mathematical has 5, 6, 7, 8, 9, 10, 11, 12. 1, 12. The first 5 must be together, so I have 5, 4, 3, 2, 1. And then I have, I don't remember how many letters was in this. 5, 6, 7, 8, 9, 12. So I have 7, 6, 5, 4, 3, 2, 1. And then what do I have to remember to do? Multiply by 8. So I get 5 factorial, 7 factorial over 2 times 3 factorial times 2. That's an 8. I don't know what you're talking about. Perfect. Leave fixed. Right there. And I don't know what that is. That is not right. My brain's not doing that. What is that?
201,600.
Okay. Now we're into these lovely paths, and you might be like, why is this in this unit? Like, where does this look like words or people walking? But what you could say here is, how many paths can you follow from A to B following the grids below? Technically, what they're doing is they're giving you a specific amount of grids to do, and they will say going from A to B, but basically you can't like go backwards to A at any point in time, which because if you could do that, it would be infinite number, right? Because you'd like go down one, circle back, go down one, circle back. You'd like literally be just walking the block. You could it'd be infinity would be your answer. So you always have to work your way from A to B. Now I'm going to show you how to do it the pathways way. Do not do it the pathways way, because we are in perms and cons. There has to be a way to do it with perm and con. The reason why I'm showing you the pathways way is so when I show you the perms and cons way and the answers match, you trust me. Okay? Not just trust me, you're like, she's right. I will do what she says. You know, instead of just that blind trust that sometimes you come in with. I want you to see why it actually comes out the same thing, and then you can trust me. Okay? So don't go feverishly writing these numbers, and don't freak out when you don't know exactly what I'm doing. Okay? So in pathways in the old 30 applied, you'd have to do it this way. So from A to B, I have one path here that can get me all the way from here. I could just follow straight because I can't curve back, right? So I have one path to get me to this spot, one path to get me to this spot, one path I could just walk there, or one path I could walk here. Some people will be like, but I can go this way. No, you can't work your way back because you can't go backwards towards A, right? So you technically only have one path to get there. And then you'd have one path to get to all of these. And then doing it the pathway way, we actually just summed up the paths that came into each intersection. So you'd say, okay, coming into this dot here, I have one path and one path, so that's a total of two paths. Coming into this dot, I have two paths and one path, so that's a total of three. Coming here, I have a 3 paths 1, that's 4. 4 paths 1, so that's 5. 5 paths 1, so that's 6. Then here I have one path and two paths, so this would be 3. 3 and 3, 6. 6 and 4, 10. 10 and 5, 15. 15 and 6, 21. 3 and 1, 4. 10. 10 and 10, 20. 20 and 15, 35. 35 and 21 is 56. And then I have 5, 15, 35, 70, 126. So there's 126 different paths you could take going from A to B, heading towards B. Okay? Lovely. Great. Don't ever have to do it this way. We're doing it this way to prove that firms and comps can do it. So technically, I have the only directions I can go are either down or right. Correct? I can go down or right. I can go right, then down, right, down, right, down. I can go down, 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 right, right, right. But the only directions I can go are down and right. If I go up or left, I'm working my way back to A. We agree? So for this, we're not going to do it the way that I did it here. We're going to go, okay, I have a down, a down, a down, a down, and a right, a right, a right, a right, and a right. So I can say, hey, I have the word der. Look at that fancy word. Isn't it pretty? So many D's, so many R's, so little time. So if I told you how many ways could I rearrange the word der, that word der specifically, without any restrictions, what would you do? Immediately go to the denominator and put what? 4 factorial, 5 factorial. And no restrictions, what would I put on the top? 9 factorial. Type that in. Remember, you can use your fraction button. Alpha length if you use the fancy ones, kind of fancy ones. Alpha y equals enter. And that's it. See, no blind trust needed. I just proved it worked, right? So, the next one has two what? Parts, correct? It has two parts. So I'm going to have to find calculate that one, and then I'm going to have to find calculate that one, and then I'm going to have to add or multiply. Well, I have to ask myself, do I need these paths up top and these ones to get me to B? Or could I just use these ones or just these ones and get me to B? You're going to have to multiply because it's and. You need the top ones and the bottom ones to get you to B. So find this dir separate, and then multiply. Try that out. So we're going to have 4 factorial over 2 factorial, 2 factorial, multiplied by 5 factorial over 2 factorial, 3 factorial, and what'd you get? Pardon? Someone? 60? Let's check it out. 1, 1, 1, 1, 2, 3, 3, 6. Then these would all be 6s. 12, 18, 24, 18, 36, and then 6D. Life is good. Trust. Shouldn't trust me with the chicken. I hit myself in the head. But you know, I'm going to try again. Watch out. I should say it to myself, since I spoke to myself in the face. I got to go on the board, but I can't say for fact that you guys won't get hit. I've warned you. I'll aim up.
Did the 72.
See, what is wrong with me now? It's the chicken. It's a faulty chicken. I won't give you this one, Peyton. My hair stuck on it for sure won't. Now my DNA is on the chicken. If someone actually got like hers, they could go back to me. Oh, it's probably because I wasn't pointing its beak. You know, there we go. Okay. See, I suck now. That's correct chicken. I don't even know what's wrong. Well, you know, you're gonna have to. I put a hole in its beak. I feel like I just can't use the chicken anymore. You better not take a picture of the chicken. You have a guilty look on your face, Chloe Kinghorn.
I still find you funny. I wasn't not listening to you.
Thank you for the affirmation. As of right now, Chloe's stuck with me last semester, this semester, and next semester. Basically half your high school career. How do you feel about that? I don't want to know after that. But I'm glad you affirmed that I'm still. You know what? It's okay. It's all right. It wasn't math. I'll forgive you. Okay. Next page. No, it's not!
Can't wait for you to come back and listen to the chicken.
Oh, the chicken conundrum. Okay, we're at combinations.
Grade 12 math class, here it is.
They don't even know what the chicken is. It is a sticky chicken that you fling. It's a, what would you call it, slingshot chicken? A little slingshot chicken? I have to tell, because if you go back and be like, what kind of chicken is she? Like a raw chicken? No, it's like a little sticky slingshot chicken.
I just love like the mental image of just a full rubber chicken getting hucked across the room.
Better than a raw chicken getting hucked across the room. Everyone duck, you'll be fine. I can't guarantee you won't get hit by the raw chicken. There's no raw chicken. Okay, combinations. Permutations order matters, we agree? Combinations order doesn't matter. So we're going to look here, discussing how throwing 3 toys in a bag is different than lining them up. How is it different? Okay, here's my 3 toys. I'll make them different colors. Here's my 3 toys. Here's my bag. I don't know why I have this on my desk. How many ways could I do that? 1. I just did it in 1, right? So if you're taking all the toys, toss them in your backpack, and scoot on your way, you can do that 1 way. We agree? So would that be a permutation or combination? Combination, because order doesn't matter. You go to the library. The librarian, you go up to her and you're like, I have $3. And she's like, cool. That's what the noise makes. I've practiced. So that's what happens. You get your $3. You toss them in your backpack. You're on your way. That's a what? Combination. How could we turn that? Wow, I kind of went through puberty right there. How? I'm way too old to be doing that. How could we change it so that that would be a permutation? The library book, Delio. Anyone know? Yeah.
Put them one at a time.
Put them in one at a time. Still in my backpack. Still walk off. You're getting close. You're getting close. Yeah.
If you're talking about the order that they were scanned in.
Sure. Both of those could work, but once they're in my backpack, I'm going home, right? Like I still got all my books. Yeah.
Maybe like when you put them in the backpack, you put like one in first, then you stack them. So then when you're walking, they don't change.
So
And then
you're,
when you get home, you'll take your
you can
back
take
one
that top
first.
one out, yes. These could all work. Here, if someone gave you these questions, you'd be like, who is the weirdo who's making sure that the books in the backpack are coming home in the exact same order? Like, you know, or who's making sure they're scanned in a specific order, right? Like, so they would work, but you would question me if I gave you that question. You'd be like, why are you weirdly ordering, like, who, yeah, you know? But how about if, and you might not know this, but you're a person who the librarian doesn't trust. You don't return books. You got like 20 at home and the librarian's like, no. And you're like, please, ma'am, I would like a book. And she'd be like, no, but I just want to read. And she'd be like, you have 20. But please, ma'am. And you're like, okay, I'll let you have one. Okay? But you have 3 that you really want to take out, correct? She's like, I'll let you have 1 a month. Okay? So you go up to her and she's like, which one? And you give her that one, right? And then when you go home with your one little book and you're sad that you have 20 at home, and she's like, dude, bring back your books. You're like, okay. And then you bring back your book, and then now you have 2 options to choose from to take out the next time, right? And then you have 1 option for the last month because you've read the other 2, unless you really like rereading books or something like that, really close together. Okay? So that would be more realistic as to like, you wouldn't hate me if I gave you that question. However, your 3 questions would work. You're just a weird person who wants your book specifically to stay in your order in your backpack. But it would work. That question would be a permutation. Okay. Now, if I want to line up these toys instead of just throwing them in my backpack and going home, so now I have my 3 toys and I want to line them up. These are some really boring toys. They're just highlighters, but don't be jealous. Here's my 3 toys. I have things I could have used next, but that's fine. Does the order matter of which I'm arranging toys in a spot? Yeah, because it could be this way, green, pink, yellow. Now they look different. Now they look different. Now they look different. And now I don't remember what order they were in the class. But they can move, right? How many ways can they move? The first spot I would have 3 options, and then I leave 1, and then I have 2, and then leave 1, and then I have 1, so it would be 3, 2, 1, 6, right? So that would be a permutation. Order would matter. All right. So if order doesn't matter, combination, and I told you this before, you're picking a subcommittee of 3 people from a subcommittee of 10 people. I don't give them jobs, combination, correct? We're going on a trip. Welcome. Okay, 3 of you get to go. Sorry. We get to go on a trip. The trip is to Edmonton. We're just going to drive there and we're going to drive back. It's kind of a crappy trip. We're not even stopping. But it's a trip nonetheless, okay? So you get to go to Edmonton and back. If you're picked 3, the top 3. You're welcome. So, would that be a permutation or a combination? Why?
Because the 3 are indistinct.
Because the 3 are indistinct. Good word. That's like a $2 word. High five. There. I'm lazy. All right. So, because you can't tell, because if you were picked first, second, or third, you get to go to Edmonton and back no matter what, which is super awesome for us. Okay? So, combination. How could I make that be a permutation? Okay.
First place gets to go to like Hawaii, second place is like Vancouver, and then third place would be like Edmonton.
Yeah. You give them different places.
Yep.
Yep. Yeah.
Or we could go first place rides shotgun, second place rides backseat, third place rides in the truck.
These are all options. Illegal, but options. Okay. We could also be like, first person gets to get off the bus of P when we get to Edmonton. Second person gets to get off the bus and get more water. It's going to have to be, which is not good. Third person gets to just watch the other 2 on the bus and drives back. You know? You just have to give them something different that if they're first, second, or third, they get to do something different. Neither of the options of which I gave were great. Yours were much better, like Hawaii and stuff like that. Yours were, yeah, better than my options except for the trunk rider.
Mine would get depending on what spot you are in the 3.
True.
It gets
The
worse.
trunk rider is not, I would rather be 4th than the trunk rider.
4th is strapped on top of the car.
It's true. 4th is on, strapped
On
on
top of the
This is
car.
getting worse. Okay, I want to be 5th. in the kayak, just air kayaking. Cool. They'd be laying down in the kayak because they're like, you'd be like, have you seen a dog at like 30? Their face is like this. 110, you'd be like, be worse than the chicken that hit me in the face. Yeah, you'd be getting hit with chickens in the face. Well, not chickens, but birds, things.
What are chickens just jumping across the bed?
We're going to Edmonton. I don't know. There could be chickens, cattle. I don't know. All right. So when we talk about combinations, order doesn't matter. We agree? That was the thing. Now, this is something to note. If I go 10C6 or I go 10C4 in my calculator, I actually have the same answer. Okay? I'm going to show you why. This is the formula for combinations. NCR, n factorial over n minus r factorial, r factorial. Do you see they're multiplying by the r factorial in the bottom? Because it's getting rid of all the different cases. Because it's a permutation formula, getting rid of the cases, right? That's what that r factorial on the bottom does. So if I plug it into here, I'm going to go 10 factorial over 10 minus 6 factorial, which is 10 factorial over 4 factorial, 6 factorial. If I do this one, it's 10 factorial over 10 minus 4 factorial, and then it's 10 factorial over 6 factorial, 4 factorial, which is, commutative property, the same thing, the denominator, right? 4 and 6, 6 and 4, same thing. So it only works in combinations, not in permutations, because permutations doesn't have that r factorial. So what can you tell me? If I gave you 20C3, what would that be the same as? 20C what? Anyone know? 20C3. Same as 20C what? Yeah? 17. This guy makes different bases for different things, and knows that that's 17. What did you do, Nathan? You did 20 minus 3, which is 17. Because all you're doing here is you're subtracting the two numbers and getting the other number, correct? So with C's, it's actually just the two numbers subtracted. So if I gave you like 30C, I don't know, I'm randomly writing these all over, but that's okay. 30C10, it would be 30C what? 30C10, same as 30C? 20. Same thing. The other thing is, you can also use these brackets. So instead of going 10C6 equals 10C4, they can go 10C6, 10C4. And that's on your formula sheet too. It shows you NCR can be written as NR. P doesn't have any options, it's just NPR. Okay? So here we have 3 students from a class of 10 are chosen to go on a school trip. 3 from a class of 10. They're going on a school trip. So they're either going on a school trip or they're not. And if you can say they either do this or they don't, it's a combination, right? Because the difference between those 3 people going on the school trip, is there anything different if they're first, second, or third? They get to go or they don't. So how would I write this? 10? What? 10C3. Now, if I gave them different things on that school trip, one gets to tell everyone where to sit, one person gets to clean up after everyone else, and one person gets to just yell at people. I don't know why those are the options that came to my head. What would change? Instead of it being 10C3, it would be 10P3. It's the only difference. So type it into calculator, 10C3. Now you're going 10, and then you're going to the probability button again, math, probability, but you're picking number 3 instead of 2. So 2, 3, and 4 are the ones we use. And what do we get? Pardon? Now go 10P3 just for fun. Give it order. What's the difference? 720? It's much larger, correct? Because now you're not just picking 3 from 10. You're actually picking the 3 from 10, and then you are actually arranging them because you're giving them jobs, right? So you're getting more. I don't know what I'm doing this. But you're getting more. It's like I'm waving at you. All right. Flip over. Looking at one more. The athletic council decides to form a subcommittee of 7 council members to look at how funds raised should be spent on sports activities in the school. subcommittee of 7 council members. There are a total of 15 athletic council members, 9 males, 6 females. The subcommittee must have exactly 3 females. So is there any jobs on this subcommittee? No, so it's a combination, right? And it must have exactly 3 females, but how many do I need to have in total? 7. So what are they indirectly telling you? 3 females and 4 males. How do I guarantee getting a female? Choosing from the females. How many females are there? 6. And I choose 3. How many males are there? 9. And I choose 4. Do I multiply or add